Ratios and proportion. Oops. Ratio and proportion is our topic today. The same thing, right? And then I want you to write down the definition of ratio. I bet a lot of you already know. Here's the definition of ratio. Somebody read this for us. What's it say? Go ahead. Jet.
The ratio of one number to another is a quotient when the first number is divided by the second.
Good. And I want you to write this one too. The quotient is usually expressed in simplest form. Okay, so when you give me a ratio, you need to give it to me in simplest form. Okay, so write this down. And here's, oh wait, okay, go ahead and write it down. A ratio of, let me show you. Okay, if I have a ratio of 8 to, oops, too much. 8 to 12, is that the best way to represent ratio of 8 to 12? No. You will write what? There you go. Okay. Also, if I have some variables, like x to y, I have to write y can't be 0 because if y was 0, what kind of numbers you get? Undefined, right? So when you have ratios, somebody read this for us. Since we cannot divide, you don't have to write this part. Yeah, go ahead.
Since we cannot divide by 0, a ratio r over s is defined only if s is not equal to 0.
Good, it makes sense, right? You have s not equal to 0. Now, this is important. This part, read this part too. Go ahead, Brianna.
When an expression such as r over s appears in this book, you may assume that s is not equal to 0.
So that's kind of nice, right? You don't have to worry about the denominator going 0. So in this book, if they give you a ratio like r over s, and you see variables in the denominator, right? You could assume that the denominator won't go to 0. Is that okay? By the way, what do you call these things when you say something like r can't be 0 and things like that? It starts with r. Yeah. Restrictions. So you don't have to write down restrictions. Okay. All right. Let's look at an example. Here we go. Okay. So let's say we have this figure. Quadrilateral. Okay, so it says find the ratio of OI to ZD. By the way, when they say OI, just without any sort of symbol above, what's it mean? It's the?
It's the
The length, right. So they're saying the length of OI to ZD. Who could tell me the answer? Yes, sir.
14.
The ratio is 14?
Ratio.
Yeah. What's the?
14 would be 2773.
So
7 over 3b.
7 over 3b. How many people agree? What do you think, Nicholas? You don't agree?
Wait, what did you say?
He said that it's 7 over 3b. Or 7 to 3b. You could say 2, right? The word 2. He said it was 7 over 3b. What do you think, Nicholas? Okay. So can I write 14 to 6b? No, that's not simplified. So you want to write 7 to 3b, right? Or 7 over 3b. Remember ratios, you could say 7 to 3b as well, same thing, right? They could use that word TO too, 7 to. All right, what about the ratio of the measure of the smallest angle of the trapezoid? Now they're telling you it's a trapezoid for the second part, okay? They're saying, what is the ratio of the measure of the smallest angle of the trapezoid to the largest angle? What do you guys think? Michael? 1 over 2. How many people agree with 1 over 2? How many people have different idea? Here, why did you say 1 over 2, Michael? Okay. Okay, but what about angle O? Don't we have to figure out what that angle O is? Because what if angle O is the largest or something? Jonathan?
everything should equal 360.
Okay, we know that sum of all these angles must equal to 360 because it's a quadrilateral. Or what's another way of thinking about it? Since it's a trapezoid, you know that these two sides are different. ZO and DI is the parallel sides. So what can you, is there another way to figure this out, Kevin?
Since those two lines are parallel, the transversal, and that's the transversal, and
Right.
two same side interior.
Good. If two parallel lines, you got to say the whole thing, right?
Huh?
You have to say the whole theorem, right? If two parallel lines are cut by a transversal, then what? What do you know about same side interior angles? They are? They're supplementary. So what do you know about angle O? It's 110, isn't it? So you're right. It does happen to be that 120 is the largest angle. By the way, does the order matter? Can I do 60 to 120? No. They ask you for What? Oh, smallest, so that was right, 60 to 120. Can I do 120 to 60? No, okay. So, but I wouldn't leave it as 60 to 120, would I? It would be 1, 2, 2, okay? Easy enough? Very simple, right? Very simple, it's nothing hard. All right, let's move down here. Oops. Yeah, they don't have that part. So who wants to read ratios part? Here, go ahead, Nicole. In terms of the same units, right? So for example, can I say the ratio of one length to the other is 1 to 2 if one of the length is 1 kilometer, the other is 2 meters?
No.
Would the ratio be 1 to 2?
No.
No, that would not be correct. That's why you have to have same units, and the book doesn't say this. I want you to write this down. Ratios do not have same units. Why? Do not have units at all. Why is it that ratios do not have any units? Because if you put down units for ratio, then you did something wrong. You shouldn't have any units for ratio. The book doesn't say that, but they should. Yeah, what do you think, John? Why do they not have?
Units cancel out.
Yeah, the units cancel out because you have to use the same units, right? Just like what the book says, right? When you have same units over same unit, for example, 2 meters over 5 meters, what happens to the units? The meters over meter is? They cancel out. It becomes just 1, right? Does that make sense? So because you have to use same units for ratios, the units cancel out. So you don't have any units for ratios. Please do not put down any units for ratios. Does that make sense, guys? All right. May I move on?
Yes.
Okay, write this down then. Let's do this example then. It says a poster is 1 meter long and 52 centimeters wide. Find the ratio of the width to the length. Go ahead, everybody try. Could it be 1 to 52? Right, so go ahead. There are 2 ways to do this. I'll wait. Go ahead, everybody try. I'll wait. One of the questions that was asked is, do you have to have smaller number first? Is that the answer? No, it depends on how they ask. So which one has to be first in this case? How about Yechan? The width. How do you know?
It says width.
Yeah, it says width, length. Does that make sense? The order does matter. Please, right? Be careful. You have to follow that. So, what is the width? Yes.
13. Oh wait, just kidding. 52.
Width is 52. What's the length?
1.
1. So can I do 52 to 1? No, it should be 52 to 100 if you're going to use centimeters. And of course, centimeters allowed, don't they? So it's going to be, how many people got 13 to 25? Raise your hand. Good. Did you guys put any units on them? Okay, good. Did anybody do this meters? Yeah, would it work? Yeah, do you get the same answer? Yes, it will be what? 0.52 over? No, not 100. If you do it as a meters, it will be 0.522 1. Multiply top and bottom by 100 to get rid of the decimals. Yeah, you get the same answer, don't you? That's what a ratio is, right? No matter which units you do it in, right, the ratio comes out the same, right? As long as you do them correctly, as long as you use the same units. Let's move on then. Any questions, by the way, before we move on? Okay, here we go. Okay, who wants to read this for us? Andrew, go ahead.
Yes, finally. Sometimes the ratio of A to B is written in the form of A colon B.
Right, so sometimes you could write A to B or A colon B, right? But you read the same way, it's A to B, okay? Go ahead, keep reading.
This form can also be used to compare 3 or more numbers.
Yeah, so it doesn't have to be just 2 numbers, it could be 3 or more. So take a look at this, keep reading.
The statement that 3 numbers are in the ratio C to D
Means, what? Yeah, right, means. So it means what? C to D, the ratio of the first number is C to D, right? The ratio of the second to last is what? D to E. What about the ratio to first to last? That's what it means. Does that make sense?
Yes.
Okay. When would you use 3 numbers like this? 3 dimensional. Yeah. Or Brandon, what do you think? So many times we're used to having ratio with comparing 2 numbers. When could you use 3 numbers to compare things? Triangles. What about triangles? Yeah, maybe the length of 3 sides of a triangle. That will work, right? Anything with 3. How about angles of triangles? Would that work? Any other cases you could use? Yeah.
When they give you a problem and tell you that you
Right. So what kind of problems would you see?
Like
Yeah.
word
Word problems that has, yeah.
Consecutive.
Yeah, it could be consecutive 3 integers or consecutive 3 odd or even. You've seen those before, haven't you? Some people said recipes, right? If you have to mix something.
Oh, yeah.
But it's more than 3 usually. It's not more, right? They're, yeah,
Wait,
they're
that
whole-
doesn't make sense.
Right, when you cook something, don't they have a bunch of...
One bread.
But they're like
No, like when they mix, like...
Mix it.
Yeah, when they mix two. Anyway, you get the idea. Okay, may I move on?
Yeah.
All right, here we go. But in math, we like to talk about triangles and things like that rather than recipes. But you could do that, right? The whole recipe thing, right, is really a ratio problem, isn't it? Let's look at example 3. Everybody try this now. The measure of the 3 angles of a triangle are in the ratio of 2 to 2 to 5. Find the measure of each angle. By the way, does this mean the angle of the triangle is 2 degrees, 2 degrees to 5 degrees? No, but the ratio is, right? So they want you to find the measure of each angle. Go ahead, everybody try. By the way, I want you to do this algebraically. I know that a lot of you could do this in your head. That's not going to cut it. You need to declare your variable, come up with an equation, and solve and write the answer in a complete sentence. It's correct. Go ahead, everybody try. I'll wait. Some of you are having trouble coming up with the declaring your variables part. So when you declare your variable, you have to use that keyword that starts with L. Let. Now, what is going to be? How many unknowns do we have here? Remember, we have 3. We have to now represent these 3 unknowns using one variable. Is there a way to do that? The 3 unknowns are the measure of each angles, right? What do you think? Let.
Let 2x equal the first angle.
Good. Let 2x be the first angle. Then what? 2x is another angle, and 5x is the last, right? By the way, what kind of triangle is this? It's an isosceles triangle, isn't it? Because remember, the 2 angles are same, right, in this triangle. So here, this is what we do, right? They just did it this way. 2x, that 2x, 5x represent the measures of each angle. Oops, sorry. Here you are. What is then the equation? How do we come up with the equation? Here, Young.
2x plus 5x equals 180.
Good. We know that sum of the 3 angles, right, of a triangle has to equal to 180. Then we get x equals to 20. Now, is that our answer?
No.
They want the measure of each angle. So who could tell me if x is 20, what is the measure of each angle? How about yes, Chan? 40, 40, and 100. And is that how we write down our answer, or do we need to write it as a sentence? So what do we write here? How about Eamon? That's right. And of course, you should check, right? Does it make sense? You could say, okay, you could add them all together. Does it equal to 180?
Yes.
Yeah, okay, so it makes sense. All right, any question? Is this pretty straightforward? Do you see what to do for your homework tonight?
Yes.
I don't want you to do this on in your head and just give me the answer. I want to see this kind of work because it's going to get a lot more interesting than just simple like this. Any questions? Yeah, I'll wait. Some people still writing. I'll wait. Go ahead. Here we go. Nicholas, do you remember anything about proportion from last year? Okay, can you tell me something about proportion from last year? Okay, it does involve ratio, you're right. So proportion turns out is an equation that, how is this proportion? It's a special equation. Anybody remember what a proportion is? It's an equation that has, yeah. Yes, but what about, Nicholas, what about ratio? Okay, kind of, yeah. Let me just tell you. It's stating that 2 ratios are equal. So when you have 2 ratios equal to each other, that's an equation, isn't it? Because a ratio is an expression, right? So if you have an expression equal to another expression, that's an equation. But this is a special equation where if you have a ratio equal to another ratio. Here's an example. A over B equals to C over D. You could also write this as A to B equals to C to D, right? So yeah, go ahead and write this down. So that's what a proportion is. Do you guys remember solving proportion problems and so forth in algebra? No? Okay.
I remember this.
What was?
It's a breadstick. It's a breadstick.
Right. Good. So a lot of you, I hear a lot of you saying cross multiply. That's a shortcut. By the way, when you do cross multiplication, like if you multiply A times D and C times B, when you have a ratio equal to another ratio, that's fine, but that's a shortcut. Why do we do that? Anybody remember why? Who remembers the algebraic reasons as to why when you have a proportion, you multiply A times D, which is equal to C times B? What? How does that work? Anybody remember? Yeah, Tony?
Well, in order to go along with you multiply each side by B first and then B.
That's right. In other words, you're multiplying both sides by the LCD, basically. What's the LCD of these two fractions that has denominator of B and D? What's the LCD? Remember what an LCD is? Least common? Least common denominator. What is the least common denominator of BD? So what happens if you multiply both sides by BD? Samantha?
You get A times B would cancel out.
The B would cancel out?
So you get AD.
Yeah.
Likewise on the other side, so you get AC.
Right. So when you multiply both sides by BD, B's cancel out, you get AD, and then on the right side, the D's will cancel out, you get BC. That's why you could do that cross multiplication, which is a shortcut. It's not really an algebraic property, isn't it? Is it? Okay, so anyway, we're gonna talk a little bit more about that later, but that's a proportion. You have a ratio equal to another ratio. Okay? Now, just like the other ones, do you only have to have two ratios equal to each other? Could you have three ratios equal to?
Yes.
So somebody read this part here. Who haven't read today? How about Kevin? Go ahead.
Either form can be read A is to B.
Hmm?
Oh, A is to B as C is to D.
Hmm?
The number A is called the first term of the proportions. The numbers B, C, and D are the second, third, and fourth terms, respectively. When three or more ratios are equal, then you can write an extended proportion.
Yeah, so you could write an extended proportion. How would you read this? If you read A to B as C to D for the first one, how would you read this one here? Yeah. Yeah, A to B as C to D as E to F. Does that make sense? So that's how you do that. Any question? Let's do some examples. Okay. Here we go. Here's our first example. It says a telephone pole 7 meters tall snaps into two parts. The ratio is 3 to 2. Find the length of each part. Go ahead, everybody try. I'll wait. You have to can you just do this in your head? I don't want you to. I want you to write it out and come up with, declare your variable, come up with an equation, solve, and write down the answer. Go ahead, everybody try. Josh, how would you declare your variable on this one here?
Let 3x be the first piece and 2x be the second.
Exactly. Let 3x be the first piece and then 2x be the second piece. And so then what's the equation for this? Okay, how about, that's what I got here. How about Nicole? Right. 3x plus 2x equals to what? Oh, you wrote 700? Could I keep it as meters? Does it matter? Yeah, it doesn't matter because then everything will be in meters, right? If you kept it as centimeters, that's fine. Then you would have your answer as in centimeters. So then what do we, so of course when you add them together you get 5x equals to 7. What's x? 7 over 5, or some of you got 700 over 5, right? So when you plug it in, right? How many people got 4.2 meters and 2.8 meters? Good. If you did it as a centimeters, it would be what? 420 centimeters and 280 centimeters. Easy enough? Can you leave the answer in fraction? No, they ask you to, you're supposed to actually write it as a sentence. I didn't. But you're supposed to write what? The length of the pole.
Like, can you do 4 and 1 third?
Oh, okay, yeah, that's fine. If you left it as a fraction, yeah, that's fine. Okay, let's look at some of the other ones now. Go ahead and try example 2, 3, and 4. By the way, what sort of instructions do you think I'm going to say for you to do? Divide fraction? No. Since we're talking about ratios and proportion, I'm going to ask you to write them in as a ratio. Okay, write them as a ratio. Aren't they already in ratio? But what kind of form do you want? In simplest form. Whenever we write down the ratios, they have to be in simplest form, okay? So go ahead, write these ratios in simplest form. I'll wait. Go ahead, everybody try. How about, Yvette, what did you get for 2? 2 over 3. How many people agree? Oh.
But for the other
Oh,
one, yes.
A over 2BC. How many people agree? Good. What about example 3? Is that 2/3? Because on the bottom you can factor out that 3. Okay. What about example 4? T plus 1 over. Should I just leave it as T plus 1 or T plus 1 over 1? Since I'm talking about ratio, right? Okay. So 2 numbers. Okay. You should leave it as T plus 1 over 1. Any question? Easy enough. Yeah. Can you write this as T plus 1 to 1? Same thing, right? Any questions? All right. Good.